So let's take a look at some examples here. Now, for these examples, what we're going to do is we're basically going to set up the hypothesis test. I'm going to here give you the p-value, and then we'll finish out the problem from there. While this is, seems like we're skipping a lot of work here, this is actually the way that you would really do it with technology. And so that's why I've chosen to do it this way. I will show you how this can be done with some technology later on. Okay, so let's read through. A pet association claims that the mean annual cost of food for dogs and cats are the same. The results for samples for two types of pets are shown below. At alpha equals 0.10, can you reject the pet association's claim? Assume the population variances are not equal. Assume the samples are random and independent and the populations are normally distributed. Okay, so let's do this. Let's say we're going to let mu1 be the mean annual food costs for dogs, since that's the one they have there with the one subscript, and let mu2 be the mean annual food cost for cats. A little sloppy there. All right, so now what we're going to do is we're going to set up our hypothesis test. Well, let's go back and look for a minute first. Okay, so what is it? They're claiming that these two things are equal. So mu1 equals mu2 is in fact the claim being made here. All right, so when we go to set up our null and alternative hypotheses, obviously the equals case, this is a mu1 equals mu2, and that is the claim. And so the alternative has to be mu1 not equals mu2. So this would indeed be a two-tailed test. Now, we will make note that the population variances are not equal. Again, we're not making the calculation here, so we're not going to see that in effect here, but it is important to note. Okay. So now that we have it all set up, all right, notice that our claim is in the null hypothesis, so we're in a rejection mode, and that's why they're asking whether we can reject the pet association's claim, but we'll see whether we can or we can't. Okay, so this is all the information here that we would have to, put into all those formulas or use some technology to figure out. Note that they are telling us that the population variances are not equal. So in that case, we'd be taking the degrees of freedom as the one less than the smaller of these two. So our degrees of freedom would be 7 in this case. And then we would use those other values to make our calculations. Now let's say you did all that and you ended up with a p-value of 0.0861. So your p-value is 0.0861. That's p. Well, as with any hypothesis test, we're going to compare that with alpha, which is 0.10. And what do we have here? We have indeed that 0.0861 is less than 0.10. So p is less than alpha. Our decision there is always reject the null hypothesis, okay, because our p was less than alpha. So now we want to talk about whether we can, what we can say about the claim. So interpret the decision according to the claim. Now again, because the claim was H0, this is a rejection mode. So did we have enough evidence to reject the claim, or did we not? Well, remember, the claim here is the null hypothesis. We showed that we had enough information to reject it, hence there is enough evidence And again, we should say probably at the 10% significance level to reject the claim. There is enough evidence to reject the claim here. That claim being that the pet costs, annual pet costs, were equal. All right, let's try another one. A magazine claims that the mean amount spent by a customer at Burger Stop is greater than the mean amount spent by a customer at Fry World. Okay, so the results of the samples of customer transactions for the two fast food restaurants are shown below. We have a 5% significance, alpha equals 0.05. Can you support the magazine's claim? Assume population variances are equal, and assume the samples are random and independent, and the populations are normally distributed. Okay. Well, I'm going to again let mu1 be the mean amount spent for Burger Shop, because that's what they've done over here with the ones, and mu2 be the mean amount spent at Fry World. Okay, and so what is being said here? A magazine claims that the mean amount spent by a customer at Burger Stop is greater. So the magazine is claiming the mu1 is greater than mu2. Okay, so that means we could go down to our null and alternative. All right, mu1 greater than mu2. That does not have the equals, so that's alternative, and that is the claim. And so the null would be mu1 less than or equal to mu2. Okay, so because we have this mu1 greater than mu2 in the alternative, we're looking at the alternative for what tail it is, that would be a right tail. Okay, and we'll make note that the population variances are in fact equal here. Again, it's not going to show here, but we'll see the effect of that later. So you go ahead and take all this information and you get your test statistic t and you find out your p-value, and so you get your p-value of 0.016. All right, so 0.016 is your p, and we're going to compare that to 0.05, which is our alpha. And what do we see? Well, 0.016 is definitely less than 0.05. So p is less than alpha. We reject the null hypothesis. Okay, now where are we again? We are looking at a claim, which is the alternative hypothesis. That's a support mode. So either we had enough evidence to support the claim, or we didn't. Well, again, our claim was the alternative. We saw sufficient evidence to reject the null hypothesis, bringing us to our claim. Therefore, there is enough evidence at the 5% significance level to support the claim. Specifically, that the mean amount spent at Burger Stop is greater than the mean amount spent at Fry World. Again, there is enough evidence to support the claim.